Just gonna mute you for a minute. All right, good morning, or yeah, I guess it is morning. It is Sunday afternoon. Thank you for coming and joining me here at Cosmic Matters. I am Matt Washington, the Matt in the Matters, and we created. I do Cosmic Matters every Sunday to kind of give people a different perspective on the world that we live in, and kind of entertain your brain for a little bit as we talk about things that are not on the normal diatribe of politics and what's going on and your daily lives. And so it's time to think a little bit grander. We talk about space, we talk about philosophy. And today I have a guest, Mr. Bose from Alabama. Bose was someone who we met on stereo back in the 2020s when the world was closed and everyone jumped on this app called Stereo. And he was one of the people who joined in on a lot of the shows that we did, where we would talk about all kinds of things. He is I'm gonna say an expert, because really being an expert just means you know more than the person that you're talking to. So I'm gonna call him an expert in, like, is it Norse gods? I'm gonna say Norse gods. Is that correct?
Yeah.
Yeah.
I mean, I know quite a bit about him.
Yes. So you're going to be you're the expert on that, because I don't. And Bose taught me the meaning of Bluetooth. I remember him explaining that to me.
I did. That's a cool thing.
And so we're going to bring him up. He does not have a camera, but that's fine. So he's going to be chatting. We're going to be chatting with his wonderful black crow.
It's a raven.
A raven. Yes, that makes more sense. That makes a lot more sense. So all right, so we were chatting about how cold it is. So I'm in New York, Bose is in Alabama, and he says it's only 7 degrees warmer there than here, if I do my math correctly. That's crazy.
Insane.
How is everyone dealing? How are you guys dealing? Like, I mean, this has to be very out of the ordinary.
Yesterday was a extreme cold snap that we had that we rarely ever have. Yesterday it did not get above 26 degrees all day.
Jeez. Now, in this time of year, so we have a level of perspective. What's it normally like in February, like January, beginning of February?
End of January is usually our coldest time of the year around here. Mm-hmm. But even with that, it's still in the high 30s, lower 40s. You know, like go outside with a pair of jeans and a Carhartt jacket on, and you'd be all right. But this year's been crazy.
Yeah.
We had snow 2 years in a row, which is I've never seen before, and I'm 33 years old.
Never seen snow in that area, or snow in general?
Like snow 2 years in a row.
2 years in a row.
Yes.
Hello, people joining us in the chat. I'm adding the chat too here. Yeah, that's so the funny thing is, in New York, I've lived basically my entire life here, and about I want to say it was 3 years ago, I finally was like, that's it. I'm not going to die of a heart attack while shoveling all this snow. And I said, that's it. I'm going to go buy a snowblower. And I went and got like the $800 throw the snow across the street onto your neighbor's house kind of snowblower, self-powered at different speeds and all kinds of, you know, ice breaking stuff. Warm hand, it heats your hands. Like, it has a self-warming hand grips, got the whole shebang. And then it didn't snow for 2 years. We didn't get more than 3 inches, so it just stayed in the box for 2 years after I got it. So I just told everyone, look, I basically paid $800 to keep the snow away. That's the way I looked at it. So,
it makes sense.
So
it worked.
It worked for a while, yeah. So now finally, I guess it's funny because it has a 2-year warranty on it, so that's probably why. So now this year 3, and I finally had to take it out of the box with the snow that just hit and throw some snow around, which worked very well. So yeah, but yeah, this whole weather thing is pretty crazy. A little, but I guess it's not really crazy. Well, let me see. When you got snow, but you didn't get like ice falling, right? You didn't get like the because that was some places got some really bad ice.
Yeah, no. So luckily they were claiming at first, this was not this weekend but last weekend. They were claiming that it was all supposed to, like, where I live was like going to be like the median of where the snow stops, and where like everything south of us was going to be like just that severe thunderstorm, tornado, like what the hell type, because how you have snow and tornadoes in the same day? What? That makes no sense. Um, but everything south of us is going to be severe weather. But it turns out that, as meteorologists do, they are 90% wrong about everything they say. And most of it was like really north Alabama. And all we got was a lot of cold rain.
Okay. All right.
But it did snow a little bit. It just didn't stick. Last year it snowed and our entire state shut down for like 2 or 3 days.
Yeah. Well, that's the I know, like, when it snows in certain places down south, people just don't know how to drive. The infrastructure shuts down. Everything. I saw some really crazy ice knocking over like a bunch of telephone wire, like power lines and whatnot, and it just going all the way up the street and things just exploding. It's pretty crazy video.
So in 2010, I think it was around 2010, Atlanta got like a foot of snow.
Okay.
And Atlanta, you can imagine, big city, airport, blah blah blah. Um, they were not prepared for the snow that they got.
Right.
They Atlanta shut down for like 3 days because they weren't prepared. But because of that, now after that, they spent X amount of millions of dollars on
Snow prep.
salt, yeah, snow prep, so that don't happen again.
Yeah, I saw a video of some, like, it's actually pretty cool, like the world we live in now, is because it's like you used to only be able to get, if you wanted to be, let's say, like a weather forecaster, you had to, like, go and try to get on channel 2 or channel whatever, and go through the ranks. And I watched this guy on YouTube now, and he just does the weather. He's got a whole Doppler readings that he gets, and he does he taps into cameras in different places. He was given weather all across, like this whole last storm. I was just watching YouTube videos. This guy doing all these weather updates, and he would do a video he would update in a video like every like 3 or 4 hours. It was pretty crazy. It's like, yeah, it's like, what? I don't need television or a corporation or someone to tell me. I'm just gonna be a weather person and just do it. It's just pretty cool. And I watched him more. I got more information from him than I do normally from the little sections of the forecast. So it's interesting world we're living in now.
Yeah, independent. I guess in this particular case, it wouldn't be a journalist, but I feel like it could be an umbrella term for what you're describing.
Yeah,
I feel like it's the way to be now. It's the most trusted source of information.
yeah, absolutely. Yeah, it is. Well, I'm not going to go. That's not. I don't. I'm not going to go down that path because I want to get back to.
Absolutely.
I want to get to the
I don't
point
want to
of
do it either.
today's show. So I don't know if you saw the topic for today.
Spacefaring civilization.
Yes. So some interesting news came out. I guess I'll start with that. from SpaceX, and I'm looking over this direction because I got to read it here. But SpaceX filed with the FCC, and I'll get the exact wording here of the filing here. In a filing to the FCC late January 30th, SpaceX proposed an orbital data center constellation of up to 1 million satellites in low Earth orbit. The satellites would operate at altitudes between 500 and 2,000 kilometers in 30 degrees of blah, 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 synchronous, blah, 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 to maximize time in sunlight and solar power generation. By directly harnessing near constant solar power with little operating or maintenance costs, these satellites will achieve transformational cost and energy efficiency while significantly reducing the environmental impact associated with terrestrial data centers, the company said in their filing. So let me just reading that, let me just get real quick a first opinion or first thought that you have hearing that information. He's gathering his thoughts. Okay.
Yeah. I'm trying to think about everything that you said. You said a lot of big words.
So they're basically, I'll make it small words. They're putting, they filed to put over 1 million satellites into low Earth orbit. Now,
doesn't that sound dangerous? That sounds a bit dangerous.
Now, where would the danger come from?
Are we not? First of all, I know that our orbit is already cluttered with satellites and satellite debris. I'm not really concerned with things falling back down, but at the same time, like, it just seems like the more we put up there, the harder it is for us to send manned crafts up there without worrying about, punctures and things of that nature, without hitting anything that's up there. I remember seeing something a while ago, like a picture of like all the satellites and things that's floating in our orbit, and like the amount is insane.
Gotcha. And I'm going to say a couple of things about that, because that's what your perception is the thought process, right?
Right.
But we're going to put some relativity into this, because we don't understand space. Like, when I say space, not meaning outer space, I mean just like the amount of space between things. So, for example, I was watching a Neil deGrasse Tyson talk, and we have we have the asteroid belt, right, between, I think it's between Mars, is it between Mars and Jupiter? I think
Mars and Saturn.
Mars, is Saturn come before Jupiter? I should know this, doing Cosmic Matters, huh?
Yeah, I think it's Saturn.
So, but we understand there's an asteroid belt, right?
You're right.
And so when you see an asteroid belt on in like a movie, you watch like Star Wars, or you watch something, you see every time there's an asteroid, they're like in and out between these rocks, barely missing. They're colliding into each other, all this stuff, right?
Uh-huh.
So if you really went to our asteroid belt with a spaceship, and like, okay, we're going to be flying through the asteroid belt right now. There's an asteroid in the asteroid belt. If I remember correctly, they're about 650 miles apart.
Wait a minute. You're saying roughly 150 miles apart between each asteroid and the asteroid belt?
Yes.
That's insane.
Right. and that we consider that, an asteroid belt, right? And because I always I know I'm lowballing that number, but how far apart? I almost call myself to the carpet. How far apart are the asteroids in the asteroid belt?
Well, while you're searching that up, I did pull up a number.
Oh, I'm a little off.
As of May 4th, 2025, there are approximately 12,149 active satellites in various Earth orbits.
I was going to get there.
Additionally, as of 2024, there's about 8,135 active satellites specifically in low Earth orbit.
Right. So we're going to talk about that. My number I came up with was about 15,000. So they're probably rounding it up. All right. So the asteroids, so I said 650 miles. I was off by a little bit. Asteroids in the main asteroid belt are on average roughly 600,000 miles to a million. Miles to a million, which is 600,000 miles. It's the same thing. They're about 600,000 miles apart. so that is right. So if we start doing math, like the pictures that you see when they show like satellites going around the Earth, and then actually, and you see that it's not to scale. To scale a satellite, which let's say the satellite is what, 50 feet, 100 feet? As a satellite.
Yeah.
So if for something to be 100 feet, when you put it into Earth, when you put it onto the perspective of Earth,
you could upscale it. Say it's the size of a football field, 100 yards. Right. Even that is nothing compared to Earth.
Exactly. You're not going to be able to. So when people show like diagram, like there's 15,000 satellites flying around. You can't even see them if you have them on the scale where you have the whole Earth in the picture. It wouldn't be. Look up in like, I remember when I was a kid, we used to actually do this. We used to actually lay on our on the front lawn of my friend Richie's house, and we would just zone out and look in the sky and try to find satellites, because you can like literally see them if you really pay attention and just watch for a very long time, and you'll catch one moving. It's moving very slowly, but it's moving faster than all the other stars, and you can catch a satellite. Like there, we got one. So the idea that the sky, the idea of us going through it or littering the sky with satellites is just, it's not.
It's not.
That's happening.
Yeah, because you're explaining it, like my brain is like wrapping around the fact that I'm thinking about it, the exact thing that I just said. Think of football fields. Right. Imagine how many football fields there are in America, right?
Yes.
Whether it be high school, college,
football, yeah,
all of it. Yeah. Bro, there's so many. And yet there's still room to farm. There's still room to live. There's still room to parks, whatever. Like I don't have a definite number on the idea of how many football fields are in America, but I promise I would go at the very end of a pine tree limb and say that there are more football fields than there are satellites.
All right. Well, let's see. Didn't give me an answer. What the heck? How can Google sucks?
Our comprehensive list of 4,000.
Oh, well, here's the thing. There's got to be at least 20,000 high schools in America. All of them pretty much have a football field.
Yeah.
So we're easily, no problem.
Easily.
Oh, hey, oh, I didn't realize I wasn't looking at stereo here. So we got a message real quickly from Know Thyself. Let's play that real quick. Hopefully.
1,000,000 satellites.
Yes.
It almost sounds like that movie, the Disney movie WALL-E. You know, where when they were leaving Earth's orbit in that ship, they had to break through the wall, the barrier of satellites on their way out into space. Yeah, I can imagine that at some point in our future, it's going to be that cluttered up there.
See, that's a problem. That's the thing.
Junkyard satellites.
And this is the, and this is the. This is one of the reasons why I do a couple of these talks that, and thank you, Know Thyself. It's not like, hey, we're wrong. It's just we don't actually sit. I mean, I could probably for maybe a future episode sit down and actually do the math. But when you compare it to the size of the Earth, these satellites that are going around, there's plenty of space. It's almost like when you hear, have you ever listened to the flat earthers talk about flying through? There's like a highly charged particles that are very high temperature, like a radiation field that's around Earth. That's why they believe we haven't gone to the moon. I forgot what it's called, the Von or something like that. And they're like, these particles are, it's 4,000 degrees they talk about. And so, you there? You okay?
Yeah, I'm good. That was my dog.
Okay. Oh, yeah, cool. What's your dog's name?
Her name is Baby Girl. She is 13 years old.
Oh wow, baby girl's getting older. She's getting up there. So there's this. So when you hear people, I've listened to a lot of people talk about like, oh, we couldn't go to the moon because we went through this. You have to go through this area of highly high temperature particles that are out there. But what those people are missing is the fact that these particles all temperature is measuring is the speed in which atoms are moving, right? So, but when you get to space, the atoms, just like the asteroid belt, they're so far apart that the temperature doesn't do anything. It doesn't there might be an atom that's moving 4,000 degrees here, and then another one that's another 20 feet away. Where you talk about with atoms, like I've talked about this before, where we talk about there's more stars in the universe than there are grains of sand. On
oh my God, you're trying to hurt my brain.
Right? Yeah. So we looked that up, and it's not even that there's more. There's 10,000 stars for every grain of sand.
That's insane.
On planet Earth when we looked it up, right? So
God dang.
So it's just we don't have to deal in these types of numbers in our brain, right? But it's just mind bending, right? So but then on top of that, when you think about like how many actual stars there are now, there are actually more molecules of water in a glass of water than there are all the stars in the universe.
Right.
Which is how small atoms are and molecules are, right? So to say like there's a molecule that's 4,000 degrees here and another one that's maybe a foot away, that's like nothing. That's like the asteroid belt, with asteroids being 600 million miles away when you put the scale. So you could go through that even though it's 4,000 degrees, but you're measuring there's not enough molecules to do anything for that 4,000 degrees to affect you. If that makes sense.
Yes. Yeah. I actually looked that up one time because I don't even know why I even like bother with these flat earthers, because a simple Google search will fix their entire problem, but they don't seem to know that. I looked it up one time about that radiation thing, the radiation belt thing that you were talking about. I can't remember the name of it either.
Yeah, I think it's called the Avant, or I forget what the name is. But go ahead.
Yeah, basically saying that there's some kind of radiation belt that would not allow us to pass through it, which apparently, from what I understand, if I remember correctly, from what I understood, what you said is factual, but also the spaceship, as it goes through it, it goes through it so fast that it doesn't affect anything.
Right.
So their whole logic about that is irrelevant.
It is called the Van Allen belt, by the way.
That's it. That's the one, the Van Allen belt.
Right. And so, there's that phrase where if you don't, the less you know, the less you know, everything can be a conspiracy then. The less educated you are, the more conspiracies you find.
The more you know, the more depression you have.
The more depression?
Yeah.
I guess so. Yeah. Ignorance is bliss, and that is true in a lot of cases. So that being said, getting back to the idea of the satellites. So the concept of the range of the satellites, what was it? It was as far as height, because I was thinking about this. I was listening to Neil deGrasse Tyson. He was talking about time, right? And how time is really just a coordinate for location, right? Because we have, like, if I was going to meet you in where you are, you would have to give me a coordinate or some kind of mark or some kind of place where I can go, but that's on one dimension, right? So that would be like on the flat Earth dimension, right? So on that plane. But then if you came to meet me and we were going to meet up at in the Empire State Building, I'd have to give you the dimension, the location on one plane, but I'd also have to give you the height dimension. Like, we're going to meet on the 37th floor. Right?
Right.
We need that. We need that as well. So then the next one, the third dimension of that would be the time, because you can have the right first dimension and second dimension and third dimension, but we need the fourth dimension. Well, the first dimension doesn't really count. That's just a point. So second and third, and then fourth, we would need the time coordinate for us to meet up. And so the idea of the height and the width and the timing it causes it not to be a problem for getting around these satellites, right? So there's not going to, so my point being is, we don't have to worry about cluttering up the sky. It's just not going to happen. There's plenty of space for us to get around. You just think of all these satellites that are up there right now. They don't crash into each other, because you have three different planes of dimensions that have to coexist for them to even hit accidentally. So we can get through it. So now let's go on to why we're doing this, though. Because
AI.
Huh?
AI.
Oh. AI. Is
AI.
that what you said?
Yes.
Yes, that is exactly why we're doing it.
That was just a shot in the dark, Maddie. Like, that was a total guess.
It's well, so here's the thing. When you have these AI data centers on Earth, more than, I think it's something like 60% of the data center that they build is just for refrigeration, but it's just for cooling it. It's keeping, because when you have these data centers going with all this power that they have to hook up to it, it creates a lot of heat. And they have to, and this is the problem that's going on with a lot of these data centers. This is what Elon got in trouble with. I think it was in Memphis, where he built the Colossus data center, AI center. And then in order to get it going, they didn't have the power, like they didn't have the electric company put the power in, right? So they just got these gas burning generators to get the thing started, and then people were like, you're polluting and you're killing all the people in the area. All right, so now eventually they're going to put solar panels on it, but he just wanted to get going because that's Elon. But this is what's going on with all these AI data, because it's not just Elon that's doing it. It's it's Google, it's Amazon, it's all these data centers that they're doing. So the first problem is they got to generate enough power to get the things going to work, and the second thing is they have to cool it and they have to be able to disperse all the heat. So the point of putting these data centers, these satellites in space, is
two problems at one time. Two birds with one stone.
You get rid of you have unlimited power, and it's power 24/7 because you put solar panels on it, and you're getting power from the sun. But since you're not spinning around on the Earth, you can just stay up there, and you're collecting power all day long.
And
there's no night in space. And then you can cool the satellites by just dispersing the heat into space. It's just right. Yeah. And then on top of that, you then you do the computations or whatever the problems are, whatever the AI is doing, and then you can just laser shoot the information back down to Earth, whatever the output is. So that's what they're now. This was just some plans that they sent out. It's not like they're shooting up 1 million rockets in the next in the next week or so.
I can see within the next 5 years though.
Yeah, I could
for sure. And something else I want to add to that is kind of related, kind of a bit off topic.
Go ahead.
Something I've been talking to one of my buddies about and some people at work about. I'm sure every guy between the ages of 18 and 40 already know about this, but there's a very popular game coming out in November, supposedly, as of right now. It's called GTA 6.
Okay.
And the reason why I bring it up is because of what you said, the servers.
Mm-hmm.
Me personally, I've been thinking about it, and start off with Rockstar has spent $2 billion creating this game. And they're expecting within the first week of its release to generate $7 billion in sales, which is crazy.
Yeah.
Yeah, just crazy. But it's, to me, if they release this game worldwide, I could kind of see it. Problem is the servers, right? If they release this game just the story mode, they won't have a problem. But if they release this game on November 19th, all of the game open, story mode and online mode, nobody's going to be able to play it. I don't see how they are prepared enough with servers to handle the amount of people that's going to be playing, streaming, whatever.
Yeah.
Like, I don't see how it's going to be possible. So that's the reason why I brought it up, because it's a very real thing that's supposed to be happening relatively soon. And I'm curious to see how they're going to do it. Like, are they going to release it all in one day? Are they going to release it by region over the course of a 2-week period or a month? Whatever. Like that would make more sense to me if they release it, by time zone. Say it's going to come. The online mode will release at 7:00, a.m. Central Time, and then Eastern Time, and then it just keeps going until it circles back around the Central. That would make sense.
But you still have the same problem of everyone playing. If I'm understanding, this game is almost like a World of Warcraft type of game where there'll be like You can do the story, or you could just have a free world where people are running around, like the movie Free Guy.
Yes. All we have to go on right now is kind of what they did with GTA 5. GTA 5 has servers. They have an online mode, and in each online mode that they have a cap of people of 30 players in one room.
Gotcha.
So I don't know if they're going to do the same for GTA 6 because they haven't released any information about it. But even if they do the same thing, it's not going to matter because you're still going to have a ton of people online at one time, especially on day one release. Like everybody, Maddie, this is me being for real. I can see an economic dip in November
because so many people are playing the game.
Because people are going to call out of work.
Hey, well, good. We need that every once in a while.
Like it's going to be a cultural event. Like people are going to be like before GTA 6, after GTA 6 thing. Like before COVID, after COVID. Like we're going to see an economic dip in America, probably in other countries when this game releases because of so many people are just going to be like, yeah, I'm not going to work for like 3 days. At least I can see that.
So I'm wondering how, yeah, we'll see. I mean, keep me, I don't follow the, if Super High was here, he would be more in tune because he plays video games. I don't play games. I don't play video games anymore. I gave it up back in the StarCraft days. That was the last game I played. So but I understand. Yeah, and so the it's the servers, it's the heat, it's the ability to, and this is what's coming down the road. It's funny because I know I've spoken to you. I know I've spoken to Leonard about this. I was actually just talking to someone. I was driving them somewhere, and I was talking to them about this concept of the massive jump that I feel like human civilization is about to take, because I feel like we go over time where there's massive change, and then it just like if you're lifting weights, or basically you can find this everywhere in the universe, like even in evolution, there's long periods of time where there's like a plateau and nothing changes, and then there's there's huge bursts or short bursts of constant growth. It's like the Precambrian age on Earth, and then all of a sudden, it was like that for a couple million years. Or you lift weights and then you can't seem to grow at all, and then all of a sudden, boom, you break out of it. And I feel like our civilization, humanity, has been like that, where it's like if I said, hey, I'm gonna have a party, and we're gonna have I'm gonna have an 80s party, people would know what that means. They would know what kind of music, they would know how to dress. If I said a 70s party, a 90s party, a 20s party, people wouldn't understand. Each decade had there was distinct difference. If I had like a 2010s party, what does that even mean? Or a 2000s party? I feel like we've gone through like about 25 years of not really any major change. Like the internet's gotten better, cell phones have kind of gotten better. But there's
more smart things.
Yeah, it hasn't been like there hasn't been a lot of definition between generations or decades. It's kind of just been, I feel like we're in a level of plateau. However, I think that's by 2030, I think there's going to be, between self-driving cars, between AI, between robotics, between the revolution of medicines and genetics. Like I feel like there's a lot coming on the horizon here, and I don't think we're quite prepared for it. because we're in this kind of lull of technology and growth and change.
Yeah, I think everything's changing so fast. Well, not everything's changing. That's the wrong words. Let me
Good.
rephrase that.
Good.
I think it's because we as regular people we can see the news every day whether we want to or not, just because we have a cell phone that will constantly update us whether we want it to or not about things that are happening throughout the world. I just saw a thing on Facebook this morning about, and I didn't dig into it. I don't know if it's real. I don't care if it's real, about China creating this mosquito-sized drone.
Mm-hmm.
And like, I didn't care. You know what I mean? Like, I was like, cool. It moved on. Like, it wasn't something that was like, oh my God, this is so, no, I didn't care.
It's almost
And
like when they
that
dropped aliens on us. We were like, oh, okay, what's going on with
Yeah.
the economy?
I still got to pay my bills. So like, why does it matter to me? Like and that's the point I'm trying to make, is like, we see things happening on a daily basis so much to the point there that it's all too much for us to take in. And even if we were like, oh man, that is so cool, everything's so expensive that we're like, well, I ain't gonna be able to buy one, so screw it. You know what I mean? So
Yeah, I hear you.
It's to the point where the point I'm trying to make is, it's not that we're stagnant, it's that everything's happening so fast that we can't really get a grip on how to react to it.
Right. Well, let me so I'll put that in context a little bit for how my thoughts are going through that statement. So it's almost like we know more because of, so like when there was that shooting at Kent State or in Texas, at a college back in the 70s, it was like people still realize, that's still like, that was such a shock. Now, because it happens all the time and it's on the news and there's school shootings all, every week, it seems like, and we have access to it. We have access to, like, it's actually interesting because like crime and have gone down, but because we can see it now, we and we have the ability to see everything that's going on and it gets reported to us. We have a perception of the world that is different than, not, I don't want to say different than the way the world is, but it's more focused on, we get the information from every day. And because the news, and because people are not just news, but people want clicks, people want your attention constantly, they're going to report the thing that gets your attention the most, right? Chinese
Headlines, clickbait.
Yeah, China is making a nano mosquito bite robots, right? So now we become almost immune to that, right? Like we get to the point where we're just like, all right, another shooting, another this, another, okay, that another atrocity happened, or whatever. I'm just using atrocity because that's as the point here, as it just as an example. But what I'm getting at, and I think that's all true, but what I'm getting at with what I'm saying is that there hasn't been, now maybe that's a function of the way our civilization is now, because we have so much information, or we have the ability to see so much more of what's going on. But I don't see big changes. Like I don't see big I feel like if there was robo taxis everywhere, that would be a big change. Or robots, are in people's homes cleaning, and that's gone. Or the economy has to change because of that thing. Or all of a sudden every major illness gets fixed and we don't die from, crazy stuff like cancer and diseases and COVIDs, and these things can be fixed on a genetic level. Like those type, like a change like that, like a shift in humanity is what I'm talking about is coming. I feel like there's a build up to that. I don't think it was going to happen like every decade, but now I think like enough time has gone by that there's a major shift coming, and AI is definitely a big part of that, because now when you have AI, like so actually I wanted to read this. It was part of the actually I think I read it, but I'm going to read it again. So launching a constellation of 1 million satellites that operate as orbital data centers is the first step. I didn't read this, to becoming a Kardashev, Kardashev type 2 civilization, one that can harness the sun's full power while supporting AI-driven applications for billions of people today and ensuring humanity's multi-planetary future among the stars. This was a part of what SpaceX said when they made this plan, with this filing. So, do you know the? I know I was saying it wrong. The Kardashev.
No, I've never heard of that word.
All right, it's basically. I think it's just it's Russian. That's why I can't say it. Usually called. No, that's even harder to say. All right, but anyway, it was by Nikolov. Of course, Nikolai. Excuse me, Nikolai Kardashev. Right. So anyway, the point of it is, it's talking about, and if Soup was here, he'd be here talking about the space, Star Trek, right? Because Star Trek is supposedly a Type 2 civilization, but a Type 1 civilization is a planetary civilization. It's a civilization where they're able to access all the energy available on the civilization's home planet and store it for consumption, right? So all the tidal energy, all the wind energy, all the sun energy that hits Earth. So we are like 0.0005 on this, as a close to a Type 1 civilization. So we'd have to harness all the energy of the planet, and we don't harness nearly any of it, right? So
which is not a bad thing, might I say.
It's not necessarily that, because when you think of it, it's not like taking the energy and using it in a nefarious way, or using it up, in other words. Like wind energy, like if we could harness the wind energy, it's not like we would stop the wind. It's just if we just put windmills everywhere, right, the wind would still happen. We're just harnessing the energy of it, right? Same thing with tidal energy. It's like you let the waves go through, and they have things that do that. So we don't. So to get that kind of energy, what will we be able to do? GTA 6 would have no problems, right? If we could harness that kind of energy. But they're talking about Type 2 civilization. So a Type 2 civilization is a stellar civilization that can directly consume a star's energy, most likely through the use of a Dyson sphere. Have you heard of a Dyson sphere?
No.
Okay.
I'm reading it now, though.
Oh, okay. So while you read it,
hypothetical constructs that could encompass a star.
Yes. So basically, you're taking all the energy not from your planet. You're taking you're be able to harness all the energy of a star, and that amount of energy.
Holy shit! There's so much energy from a star.
Yes. Yes. Yeah. And our star is like a little star.
Right.
Like on a cosmic
it's a baby
level,
star.
Yeah. It's Do you know actually? I did a show on this where I talked about the different stars and the sizes. So the constellation Orion, right?
Yep.
So Orion, if I want to say correctly, is left shoulder. It's either his left shoulder or his right shoulder. Is a star called Betelgeuse.
I've heard of it.
Um,
It's fucking massive.
yes.
It's like on a scale that, once again, with a whole more stars than the grain of sands on Earth, hurts my fucking brain.
Yes.
Because yeah, it's fucking massive.
So it's about 1.8 million Earths that can fit into our sun.
Right.
Come on, just tell me the answer. I got to go to Grokpedia for now instead of these stupid websites. And of course, I can't see very well. If I remember correctly, it's something. No, that can't be right. Just give me the answer. I don't need to see the math. Oh, geez. Okay. So 1.2 billion suns.
Oh my God.
Could go into Betelgeuse.
Yeah.
Which makes something like close to an order of trillion Earths. Something more than I think it was like, if I did the math, I remember I did the math for the show, but it was something like a couple of trillion. It was either 2 or 3 trillion Earths. So, yeah. So we're talking a lot of energy.
Bro, I typed that question into ChatGPT.
Mm-hmm.
It took it 43 seconds to do the math.
What did it come out with?
So it says, if you mean Betelgeuse, because I misspelled
it. Yeah, that's fine.
The answer depends on what fit means, because the star's radius is still measured with a bit of squishiness.
Yes.
It's pulsing, lumpy, red supergiant. By volume, the usual meaning, number of Earths that can fit inside Betelgeuse is basically the volume ratio, and it gives me a fucking math problem.
Right.
Using a commonly cited estimate that Betelgeuse's radius is about 724 times the sun's radius, plus that comes from NASA, plus standard nominal radii for the sun and Earth, you get 4.9 times 10 to the 14th power Earths. That's about 490 trillion Earths by volume.
I always lowball just because I don't want to go over. So yeah, that's a lot.
Sorry, my wife woke up and my dog is happy.
That's fine. So yeah, so I was off. I said 2 trillion. I said a couple of trillion. So yeah, 490 trillion Earths.
That's insane.
Yeah. I did a whole video about this, like, why haven't we seen aliens? And it's like, if you really think of the size of the things that are out there, because think of how much gravity that thing has, and then how big the planets could be, and then how big the things that could live on those planets would be. So it's like Earth is nothing. It's it's like an atom.
Yeah.
So why haven't they come to Earth? Because they can't even walk on Earth. They can't even do it. It's like a little space rock, and so it's nothing. It's an asteroid. It's a comet.
And then on top of that, like you got me thinking about black holes, because of I watched a video with that Cox dude. You know what I'm talking about?
Brian Cox.
Yes, Brian Cox. He was talking about our sun, how small it would have to get to turn into a black hole. He was talking about how how big our sun is right now, and he said for it to generate into a black hole, it would have to get into a diameter of 3 meters.
Yes.
Could you fucking imagine?
Yeah, it won't happen for our sun, but yes, it's mainly because what has to happen is the gravity has to, because the gravity has to go past the electromagnetic force of the atoms trying to push each other apart, right? So that gravity pulling in has to surpass that. In our sun, because it's not big enough, it won't pass that barrier, so it'll just turn into a dwarf star. But a star like a Betelgeuse or some of these massive, supermassive stars, Rigel is another one that when they run out of their fuel, then yeah, that collapse will most likely turn into a black hole, because it'll go right past that. The force of gravity will overcome the electromagnetic force of the molecules trying to keep themselves apart. But
I just think the like putting that perspective in like visualizing that is because it's like you said, there's like 1.8 million Earths could fit inside the sun, and then for the sun to collapse into 3 meters is like I'm closing my eyes trying to picture it, and it's insane.
Yeah, we can't. These things are, and it's funny. It's like we have all these stories and made up things, but when we don't have to make up stuff. There's enough crazy things going on in the actual. If you want to look, one of my old shows also I did it with Soup, and we were talking about just how crazy Uranus is, and how it rains diamonds because the pressure of the atmosphere is so strong that it crushes carbon in the atmosphere, and then it falls as diamonds.
Yeah,
it's like crazy stuff goes on, and that's like in our solar system, in a little tiny planet, wherever it is out compared to our sun, not what is actually going on in these 2.5 trillion stars that are out there, and all the different stuff that can happen. And then on top of that, one of the reasons why Star Wars is one of my favorite movies of all time is because it starts off a long time ago in a galaxy far, far away, which means it's in the past. We think of it as a futuristic movie, but it's in the past.
I never thought about it like that. But it makes sense because of how light works. Hold on.
Oh yeah. Oh yeah. Well, yes, we would be looking at that we could actually see that happening.
It would make sense because of how light travels.
So wow. Yeah,
we've had made me think of something totally new. Because it would be a long time ago from our even if it's right now from our perspective, it would be a long time ago, depending on how far away it was.
It's outside of our galaxy, so that would be quite a far away. So
to get to Andromeda, isn't it like I forget the numbers.
Oh, Andromeda and Andromeda is getting closer to us. Actually, I just did a whole video. I have a lot of these podcasts now, because I did a whole podcast on that, on traveling to Andromeda, and the idea that Andromeda is going to crash into the Milky Way. And then I did a video, I think this was like 2 or 3 episodes ago, where I had a mathematician talk about the probability, even though Andromeda has, I want to say, close to 5 billion stars, and the Milky Way is smaller, has only about 100 million. But the odds of any of the stars collapsing into each other is like 0.0013% based upon how much space is between each star. Even when all these things crash into, even when the two collide into each other, like we won't even notice.
So when you say becoming a spacefaring civilization, you're talking about becoming a type 2 civilization, or
so that's what they put into their
are you talking about going to Mars?
No. I'm talking about, so if you can harness so there actually was just an experiment that was done where they were able to, they basically created warp speed, but it was for a very brief moment. And I got to look up the study again. And it took a lot of energy, and it was just basically they moved a particle through it basically with warp speed. What they're doing is you're making a bubble, so you're traveling, but you're traveling outside of time or inside of time, if you want to say, however you want to phrase it. But you're not traveling distance, you're traveling through time. So it's almost the way it was explained to me that made sense was like if you were a two-dimensional being and you had like a room, so you're only two dimensions, you're just, you're flat, right? You're a flatlander. And you were in a room on that dimension, and you had all these squares around you, right? Because they're flat, and you needed to make more space. Let's say you wanted to put more squares into this room, but you had no space on that second level. If you could push one of the squares into the third dimension, it would go up, and up would disappear, like, because it would be nothing. It wouldn't make sense to you. You'd be like, what is up? Up doesn't make sense on a two-dimensional level. So, but it would just seem like it would just disappear, even though it would turn into basically a cube instead of a square, and it would go, and it would look like it would pop out of existence. And then now you could, in a three-dimensional room, you could, if you're on a second level, on a two-dimension, you could put a lot more squares. You can, have lots and lots and lots of squares creating cubes in that same room just by adding another dimension. But on your level plane of existence, you don't see anything. You just see it seems to disappear. And then if you pulled it out of like thin air, which is actually you're pulling it from the third dimension into the second dimension, it would come back, and you'd be like, what the hell is going on? Well, that's the same thing as putting things from the third dimension that we live in into the fourth dimension of time. You could literally go into time, the fourth dimension, in one spot, and come out in another spot, and no time would pass. You would just reappear someplace else. This is kind of what warp speed is, because you're not traveling in the third dimension, you're traveling basically in the fourth dimension. So they were able to do this with a particle for like a split second. So I gotta find the watch movie. I'll put that on my notes for next week. But the thing is, you need a lot of energy to do this. So this is the point, is if you could start harnessing the energy of a type 1 and then get to a type 2, the amount of energy that you would have, you would be able to then do quantum computing. You would be able to have the power to create a warp drive, or figure out how to do these things. Right? Again, it's magic and science. It's magic and nonsense to us now, but it's like us talking to someone from the 1700s about cell phones and the internet. It would be magic and science and nonsense to that person. Electricity would be nonsense. So, but now it's just a commonplace. So that's where they're looking to go. Now, by the way, that's a type 2. There's a type 3 civilization, which is called galactic. And
yeah, I was about to say galaxy.
Yeah, type 3 civilization can capture and harness all the energy of all the stars in a galaxy. So we're not.
Why
even
would you even
about
need that much energy?
Well, I
Like-
don't know. Maybe you're trying to go through black holes. Who knows?
The
Maybe-
Jetsons.
so type 2, I think that's why they put type 2. And it was actually funny. Somebody wrote, has this been the first time an FCC filing has used the Cartesian scale of a type 2 civilization in the actual filing? And it was like, yes, obviously, because no one's actually ever thought about trying to get to a type 2 civilization.
Yeah, when you said type 3 and galactic, my first thought was the Jetsons.
Well, I think the Jetsons would only be a type 2. Maybe
think
even
so?
type 1. I don't know. They might even only need to be type 1. Because they're not, the Jetsons were all staying on the same planet.
I remember them being in space.
I mean, okay, we really need Soup for this, because Soup has a whole theory about how the Jetsons and the Flintstones are on the same planet.
I agree. Yeah,
Right.
The Jetsons are rich and the Flintstones are poor.
Right. But they're still on the same planet. The Jetsons are just flying around above them.
Yeah. So, well, if they're not in space, then I guess they would be a type 1, type 2. I was trying to think of something that would be a type 3 that I can visually see, and
maybe the engineers from Prometheus. But even them, I don't even think they would, you would be able to, with that kind of energy, create universes, create black holes.
That's it. No, we don't need that.
Right. We don't need
that's bad. That's stay away from that.
Well, if you go back to episode 3 of Cosmic Matters, where I talk about our entire universe is in a black hole.
Do you think that?
Oh yeah, 100% now. After doing that episode and finding all the evidence that I could find, yeah, it's pretty crazy.
You think black holes are entryways?
No, I think so. Right now, the universe is expanding faster than the speed of light. Right? Do you know that?
Sounds familiar, but
so our universe is expanding.
I don't think I actually knew that.
Okay, so our universe is expanding. This is my problem. My problem is I think I'm a part of the Borg, and when I learn something, then obviously everyone on planet Earth knows the exact same thing. So that's my faux pas of life. So yeah, so the universe is expanding faster than the speed of light, and people say, well, you can't go faster than the speed of light, and that's true inside the universe. There's nothing, and the only reason why the speed of light is a thing, it's misnamed. It's just when you shed all mass, it's just E equals mc squared. When m is mass, when you shed all mass, the fastest you can go, c squared, is light, right? As energy equals
yeah, but you can't have any mass to go to
right. Once you shed all mass, you are now going as fast as you possibly can.
Right.
And inside the universe, according to the laws of relativity. So that's basically it. So, but the universe is not subject to the universe. The rules inside the universe is not subject. The actual entire universe is not subject to those same rules of physics. And so the universe has been expanding. It's expanding. Yeah, it's expanding faster than the speed of light, because we can see how fast the galaxies are all separating.
Expanding into what? It's already fucking massive.
So now you get to expanding into what is, and then you get to the point where something like, I think it's like 86 or 90%, I'm probably lowballing it again, of the stuff in our universe is dark energy or dark matter, and we don't know what it is. It's only something
we don't know what it is.
Like only like 7 or 8% of the universe is all the stuff we see, like the stars.
We don't know what it is.
Like the Betelgeuse and the galaxies and all the things that we're saying. That's like that's less than 10% of what's actually here. So what is pushing the universe? Because honestly, what should have happened is with the idea of gravity, as the universe expanded, without some kind of force to keep it going, it should be contracting on each other. The gravity of everything should pull itself back together. But that's what they see. They see things are still separating. Still, the Big Bang. Like when people say the Big Bang, they think, oh, well, that happened 13 billion years ago. No, it's happening today. We're a part of the Big Bang. It's still banging. It's still,
for lack of better words.
Yeah, there you go. We're a part of it. So because an explosion is like when things are flying apart, you say the explosion is still happening. Well, it's been happening for 13.2 billion years, and it's still things are still going, and there's more energy. So that's what dark energy is. Dark energy is what's pushing the universe apart or spreading it. And so they don't know where that's coming from. Now, my hypothesis is the energy is coming from the universe that we're in, that we're just inside of a black hole of another universe, because a black hole is when everything goes to one point. And the beginning of our universe came from one point. So as that black hole expands in the bigger universe, it pulls things in, and that energy goes into our universe. And that's
so you think Interstellar has a point or is way off?
The movie?
Yeah.
Well, it depends on what you're talking about. As far as the idea of
Matthew McConaughey went into the fourth dimension, right? Like that's when he went inside the black hole.
If I remember correctly, he went into the fifth dimension.
The fifth dimension. All right. So that's not exactly what you're saying here. What you're saying is if a person could go inside of a black hole and live to tell the tale, it's your theory is that it would open up to another universe.
My hypothesis is there is a yes, because everything that falls into a black hole, black holes don't suck things in; things fall into them.
Correct.
A black hole is a three-dimensional gravity. It's basically a three-dimensional hole, and so as things fall into it, they go down to an infinite point, one point. And everything that falls into a black hole is all the mass that it's swallowed is still inside of it.
Yeah, because we don't know where it goes.
Well, no, they've done the mathematics of it is it's still there. And actually a black hole size is, I forgot the name of the equation, but the size of a black hole is directly proportional. There's an equation you can do to the amount of things that it's swallowed. And the idea is if you did the calculation on our universe is the exact size based upon how much mass is in it that a black hole would be. Like if you took all the math, if you took all the stuff that's in the universe, all the mass, that calculation shows this is how far, this is the diameter of what the universe would be based upon.
So would our universe,
episode 3, everyone go check out episode 3. I can talk about a lot more detail.
Damn, you got my brain pumping. If so, what art? I feel like this is not a question you would know the answer to, and if you don't, it's fine. It's whatever. We see that there are there's a black hole at the center of our galaxy, right?
Yes.
It's not even. It's a I guess a normal size black hole. It's not a supermassive black hole. It's not a big one. It's a relatively small one compared to other black holes. that have been found throughout the universe. So our galaxy, you're saying that if you calculated the expansion and like the size of our galaxy, our universe, it would equal up to the size of a black hole that it could have could be in.
So yeah,
Would
so
that
our
be like a
universe,
supermassive black hole, or
our
would it be a
universe would
normal
be
size black hole?
our universe would be a black hole. Like, so we, like you just talked about, like there's a black hole in outside of our universe, and every universe that galaxy, every galaxy so far that we found, even though we only know about, studied about 10% of them, has so far every galaxy they found a black hole in the center of it. And also then there's just random black holes that are floating out there that aren't galaxies. So what I'm saying is every black hole there that you see there has a galaxy inside of it. All the stuff that it has a galaxy, has a universe inside of it.
Right.
So when you ask, what are we expanding into? When you say, what are we expanding into? That is my answer.
Yeah, I've thought about the idea of universes being inside of black holes before. The thought has crossed my mind. But I think about it as much as I do the idea of parallel universes. Like, I don't have the answer to either one of those things, so it just sits on a super far back burner of my brain, and like every once in a while it might pop up, but I'm like, well, I don't really know. So like the idea of there being like you said, bro, we don't know what dark matter and dark energy is, but we know it exists. So could that be a thing about parallel universes? I don't know. Maybe not.
So
I don't know. But the idea
there
of
might be a parallel universe, I think that is viable as well, but that's on a completely different. It's on a complete. So, like for example, it's not like you have to have one or the other. One doesn't cancel. The idea of universes being inside a black hole doesn't cancel out the idea of parallel universes.
Of course, it doesn't.
So you have both, because
why?
when you finally really break your brain on all this stuff,
which you clearly have,
big and small it doesn't mean anything. It just doesn't. You think of like quantum mania, right? And all the stuff that's going on at a small level. Like the idea and the concept of big and small don't, in the universal perspectives, like it's everything has its own level, and it's just you can continue getting bigger and bigger and bigger, or smaller and smaller and smaller, and it's just what's going on at that level. You think of the level of even in your own body, like you think you're a person. you have this identity of who you are, but there's 2 trillion cells, individual living cells in your body. 54% of them don't have human DNA. And there's this organizational level that's going on that you have no clue about. You don't pay attention to it. It doesn't mean anything to you. And you constantly do things. You're moving your hand. You're making up these words that are coming out that you did. How do you even come up with that? How do you know how to do this and push enough air through your mouth? You're not consciously thinking about any of this stuff. It's just happening.
Right. And 54% isn't even human DNA. That's insane.
Yeah, some say 70%. I go with 54. It makes me feel that's the lowest number I found.
Because it's cosmic stuff?
No, it's just different viruses, bacteria. Most of your gut biome is made up of. In a lot of Asian cultures, like we center ourselves in our heart, and in our head. In Western civilization, we think that's where we are, but in a number of Eastern cultures, they center themselves in their gut, and they think that this whole body is in your mind, and everything is just your gut trying to find food, food and reproduction.
I can agree on the second part.
So they center themselves there, and that's, you know, because if you eat different food, different bacteria changes you change the bacteria in your gut and in your intestines and whatever, and then you all of a sudden feel differently. You have different emotions, you have different thoughts, you have different, all kinds of stuff happens differently.
Food does make you happy.
Or sad, or tired, or all kinds of stuff.
But that's all in the how I'm about to use it, and I hate this phrase. I feel like I've told you that I hate this phrase before. It's how we've been raised to believe is that, like, in our Western country, what we've been raised is that our conscious is in our mind, and that's just something that has been ingrained in us, whether actively or passively, since birth, and that's just how we think. And I can see how other cultures could think differently, because that's how they were taught, passively or actively. But I don't know, man. It's weird to think that we don't, like, I'm trying to gather my thoughts. I'm sorry.
That's okay.
It's weird. It's weird to think that
good
half of the crap that goes on in our bodies is, like, we still don't even know. We're out here searching for the stars and shit, and we don't even know everything that's happening inside us.
We don't know.
And then, like, the idea of consciousness, the idea of whether or not, like, it's 2026 and we still don't know if a soul exists.
Bose, when you get the whole theme of my show over time is basically, you know, it's all just a game. It's all just fun that the universe is having. And actually start diving into what we think we know. I did 2 shows ago, I did a show on emergence, and you know, how all these things, how smaller things emerge into bigger things that are completely different than what they are. You know, like water is wet, right? But an H2O molecule by itself is not wet. Wetness is a thing that is an emergent property of a bunch of H2O molecules just being close to each other. Right? But it doesn't happen when, you know, molecules of bark are close to each other, or this pen, or this other. So we have these emergence, and so we are the people we are is just an emergent property of all the things going on inside of our body. But
I see what you're saying. Like, all these small. I see what you're saying. All the small things are making up to this big thing that we consciously know about, but we're still learning about the small.
It's really an illusion, though. It's almost like when you see one of those pictures that are made up of like a whole bunch of other pictures, and when you zoom in, you're like, oh, it's just this. You can't even see what the bigger
mosaic
is. A mosaic, yes. There you go.
Yes.
But then you zoom out and you see this one picture, and you can't see any of the smaller pictures. But that one picture that's made up of all small pictures, what really exists? Is it the big one or the small one?
Yes. That's the answer. Yes.
Yes. Yeah. Yes. And that's true. It's all just the universe playing a game, because it's going to be around for eternity. And what else are you going to do?
Expand and learn more.
Expand, contract, multiple universes, black holes, whatever.
We're a civilization based off of creative building
and destroying.
That too.
Yeah,
but not always in a negative way.
No, but you have to. It's like what's his Galactus. He's a necessary evil. He's got to.
It's like burning your yard. It's like burning your grass in the fall.
Yeah.
To grow better grass in the spring.
Correct. You can't things. But when you think about it on a smaller scale of that, it's just, it's literally, there's nothing gets destroyed or created, just gets shifted around. The forms get destroyed or created, but not the thing, which is the universe. It's just taking different shapes. It's like a whirlpool forming in the river over here and then disappearing and forming in the river over there. All the same river. The whirlpool is just a form. It's not even a thing. It's if you try to pick it up, you can't capture it in a bucket. It's just what the river is doing.
Right. It's all an illusion.
Right.
Exactly what you said earlier.
Right. We would call it a river. We call a whirlpool a noun, but it's not.
But then you zoom out and you realize it's not even water. It's something else entirely.
Exactly.
Fuck me.
All right. Hey, you asked for this.
I did. You're right. I'm good with it. The problem is that you're making me think a lot, and I'm trying to put it all into words, and there's like I said, you're making me think a lot about a lot of different things, whether it's just like you said a while ago, big and small, from the galaxy perspective all the way down to what my eyeballs can see. Yeah. And those are two entirely different things. Even though I know that there are people out there much smarter than I am that tell me about black holes and Betelgeuse or juice or whatever it's called, or Andromeda. I've never seen it. How do I actually know that it's real? Other than the fact that other people that are way smarter than me have told me. But even then, like, I don't own a microscope. So things that I can't see that are too small for me. Also, how do I know they exist? Only because other people have told me. All I can do is like believe what I see, but also trust the opinions of people like you, people that are way smarter than me. And
I'm not way smart. I just know different things.
And I'm still thinking about the whole universes inside black holes thing. That is crazy to me.
Go
to think that
watch my episode 3. It's my favorite episode where I talk about
it. To think there are other universes out there that we don't even know about.
Yeah, well, in the center of every. Well, and then just think about how big the universe is that we are a black hole in.
That's what I'm saying.
Yeah.
Like, and I don't even know how big we don't know how big it is.
Well, this is
we can only see the observable universe.
Right. Well,
there's an unobservable universe.
Well, yeah. Well, because the universe, because like I said, the universe is expanding faster than the speed of light. So the things that are on the edge of the universe, the light will never get
wherever
to
that is,
because the universe is expanding faster than the speed of light. So that light can never reach us because it's constantly going the wrong way. It's like light trying to escape a black hole. It can't go fast enough to escape to reach the escape velocity of the gravity of a black hole, which is why it's called a black hole, because light can't even escape it.
I got a question.
Yeah.
Maybe you have an answer to it. I know that in order for we already discussed it. Something to reach the speed of light, it has to lose all mass.
Right.
What, say a black hole is consuming, I guess is the right word, a planet, right? A planet has mass, it has matter, it has everything that the speed of light negates, right? So what destroys the mass to make that planet eventually lose all mass in order for it to reach speed of light to go inside of a black hole?
So when you go into it, when something goes past the event horizon of a black hole, it doesn't go the speed of light. The speed, what the only reason we talk about the speed of light with black holes is because the speed of light, so everything has an escape velocity, right? So there's a certain escape velocity. You have to go a certain speed in order to escape Earth. I forgot. I did a whole thing on it, and I don't know the numbers off the top of my head. But if you go that same speed and you're on the sun, you're not going to escape. You're not going to fly. You're not going to take off because got more mass, right?
Right.
So the point being is you have to continually go faster to escape the gravity. But a black hole has so much gravity that even the speed of light, which is the fastest you can go, is not fast enough to escape.
Okay, so I'm thinking of it incorrectly.
Right. So now if a planet just falls into a black hole, it'll get spaghettified, it'll get pulled down to its atoms, because what's happening is the gravity right now, when you're standing on Earth, your feet are being pulled are being pulled more, or have more force towards the Earth than your head does, right? Because a molecule in your head and a molecule in your foot, because you're closer to the center at your feet. Now, if there's a black hole is like, just imagine Earth, but take away the Earth, but leave the gravity. So now you would just keep falling, but eventually what would happen is your feet would get pulled. They're getting pulled faster than your head. So you would get pulled apart because it's traveling faster, because it's closer to the center. And so this is what happens, and you get spaghettified literally to the atoms, because you're falling at different speeds and forces of your body. So and then it just turns into, then everything, when it reaches the center, becomes it's just an atom. Everything squished down to one.
You did answer my question.
Okay.
The answer is, I was thinking about it incorrectly. I've actually, while you're talking, I was visualizing. Like if you got like a sheet, like if you got like a trampoline bar, like without all the net and everything, you got trampoline bars in a circle. You got like a black sheet, and you painted it with the blackest paint that exists.
Right.
And you put like a little center hole in the middle of it, and you have it sloped into a center of a thing, right? You have it sloped into the center, right? And let's say you threw a ball into that center hole, it would disappear, right?
Yes.
Same with, like said, the blackest paint on Earth. You shine a flashlight into that hole, the light from that flashlight would also disappear. Both things disappear together the same way.
Mm-hmm.
One is just it's like you said with the parallel universe and Big Bang, not big the black hole thing. Both can be true at the same time. Because my question was, what destroys the mass of a planet? But that's not the right question. The question is, the answer is, nothing destroys the mass of a planet. The planet just gets eaten up by the dang black hole.
Right. It just gets
And
pulled
so
apart.
like everything gets eaten.
Yes.
And that's
eating is a wrong way to think about it, but
correct. It's just the best way I can explain it.
That's why I like the word spaghettified. It gets spaghettified. It gets pulled into a long string. of atoms because it's falling. Like we don't like we think like right now. Are you standing up or sitting down?
I'm sitting.
All right. So if you're sitting on your legs and on your butt, you feel pressure going down. Well, you feel pressure. You feel something, right? And what you're feeling is the force of gravity because you're literally falling to the center of the earth. Just happens to be you have a chair in the way that is stopping you from falling, and that's
Thank God.
That's what you're feeling right now.
Watch that movie.
But that's so. I just think that's an awesome. I just think it's an interesting concept. Like it's almost like when you feel the force, like when you're in a car and you hit the accelerator fast and you get pushed backwards. That's you're feeling inertia. What you're feeling right now is the force. You're feeling gravity.
Right.
You're literally falling, but there just happens to be something there that's pushing up against you to stop you from continuing your descent to the center of the earth. Right.
Seeing that movie. It's terrifying. I don't want to do that either.
Oh boy. All right. We're closing in. Actually, it's about time to wrap up. We covered a lot. I didn't get too much into the spacefaring civilization today, but I enjoyed this. It was good. I'm glad you joined.
I always enjoy talking to you, Maddie. We need to do it more often, to be honest.
I will. Well, anytime you want to, I'll send you the link. I have right now. It's just soup. I send the link every Sunday. You're more than welcome.
I'll tell you what. Next time, I would love to do this again. Whenever you're ready. If you don't mind, next time, give me like a heads up about what the topic's going to be about.
Okay.
And I will take notes myself. I will do, a few days of research, and that way we can like try to stay on topic a bit better.
Sounds good. The problem is I never know what the topic's going to be about. So it's funny because like the last like maybe 4 or 5 weeks, I was like, I don't know if I'm going to even do the show. And then like something comes up or something pops up on my feed or my algorithm. And I'm like, oh, okay. I want to talk about that. Like this thing that I just talked about with the Kardashian and I mean, they just filed that FCC thing yesterday. so I have I'm like, oh, now I want to talk about this.
What did they have a time? Like
a timeline?
Like, yeah, like how long they expect before
they launch the satellites? Well,
they don't. Even beyond that, like because you were saying the article was like, with these satellites being launched, right? It may be able to take us from a type 1 to a type 2. Is that what you were saying?
No, this would be the beginning.
The start
of getting us to a type 2 civilization. Yes.
Right. Okay.
Not yet. Okay. 1 million satellites won't do nothing. Actually, Elon, somebody said that to him, and he said, did I say? He made a joke. He's like, did I say 1 million? I meant 1 billion, because that's what it's going to take to get us to even close to a type 2. But no, they just said this is the beginning of bringing us to a type 2 civilization, because it won't. I mean, it'll move us forward again, because a type 1 civilization uses all the energy of its planet, which would consist of the energy of the sun hitting the earth, right? And for that, like the sun puts enough energy on the earth in 1 hour to power everything humanity does for a year.
Right.
We just don't capture it. It just lands and grows plants and stuff. and we're on a planet that you could fit 2 million of them into the sun now. So we're just like a little planet that's catching a little bit of the sun's rays.
Right. But catching
radiating in 360 degrees in 3 dimensions.
Yeah, catching all the sun's rays would be a monumental task for us.
Right. Yeah, we're not even, like I said, we're not even a point percentage of a type 1. But they were just saying this will be the beginning of moving. You know, Elon's always talking about the future. It's all future stuff. So this would be a first foray into getting us towards a type 2. We got a message on stereo from Hello Tutor. Let's play that real quick.
Tick, tick, tick. Uh-oh. Hello Tutor is finally in the building. That's right. The founder of Clean Talk for Clean Folks has arrived. And it's your turn, Phil, to speak with Hello Tutor. I've got an idea for a future show for you since you're techie. And the steps towards humanity becoming a level 1 civilization on their Kardashev plane.
Kardashev, see, that's how you say it.
How about that? Kardashev scale. Think that might be something worth talking about.
Yes, Hello Tutor. By the way, I just changed my name on here. This is Matty Wash 76 on stereo, but now I'm Philosophy Man 76 because I'm Philosophy Man 76 on YouTube and Philosophy Man 76 on TikTok. So I decided to make everything the same. So yeah, but yeah, in order to even get us to a type 1, we're going to need the AI robots. We'll do a whole show on it. That's a great comment, and I will do a whole show on it. Even though it's going to take multiple shows because you got robots, you got AI, you got the satellites, and all these things converging to make this happen. And that's why I feel that's where we're going. I feel like that's the direction that we are. The problem is that humanity can only go as fast as the slowest human, and there's some really slow humans holding us back.
You said it, not me.
That's how it goes. Slow, not in speed terms, not in mental capacity, but everybody understands what I'm talking about. So
I say both.
We have 25% of the United States that thinks that the sun goes around the earth. So what are you going to do? We got a long way to go. Anyway, we're not going to get there today, though. Bo's really glad you joined. Hopefully, I gave you enough mental thoughts to get you through the week to chew on.
Absolutely,
the whole week. And we're here. I'm here every Sunday, even though I say to myself every Sunday I'm not going to be here. But this is episode 22 of Cosmic Matters. If you want to see any of the past episodes, we are I'm on YouTube under Philosophy Man 76. You can check it on TikTok, or you can go to Spotify if you want to check any of the old episodes. I have them all up on Spotify under Cosmic Matters, so you can check it out there. And even if you don't want to check it out, go check it out and just give me a click of a button, so therefore it gets put out to more people, because I think we need more discussions about just what's going on in this crazy universe that we live in. All right, Bose, thanks again, man. I appreciate it. It was great talking to you.
The pleasure is all mine. I appreciate you letting me come on.
All right, thank you, people in stereo, and I will we'll see you all next week. And I probably will be on sooner, just hanging out and chit chatting.
All right, Matty, I'm gonna dip out.
All right, talk to you later. All right, here we go, end the stream and.